Keeping up with our motto that learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students! Today we are going to continue with Class 10 Science and Technology Part 1, Chapter number 5, Heat. Topics that I am going to cover during this session are anomalous behavior of water, dew point, humidity, and specific heat capacity. In general, when a liquid is heated up to a certain temperature, it expands, and when cooled down, then it contracts. However, water shows a special and exceptional behavior, which is called anomalous behavior of water. Let us understand this behavior. Over here you can see, suppose this is the water at 27 degrees Celsius. When we cool this water, then the temperature of the water decreases. As we have seen that on decreasing the temperature, when the water is cooled, then it starts contracting. So initially it contracts. Till 4 degrees Celsius, there is a contraction of water, which is quite normal. But suddenly from 4 degrees Celsius, when it is cooled further, the temperature again decreases, but suddenly the water starts expanding. And at 0 degrees Celsius, the water starts crystallizing and then it is converted into ice. If we see in the reverse direction, when the water is heated, that means when this ice is heated, then from 0 degrees Celsius till 4 degrees Celsius, the temperature increases. So when the temperature increases, it should ideally expand, but it starts contracting between 0 to 4 degrees Celsius, and then again from 4 degree to 27, that is further if it is heated, then it will expand. So the behavior of water between this 4 degree and 0 degree, it is quite different. This behavior is called anomalous behavior of water. Also, when we cool down the water from 27 degree to 4 degrees Celsius, it was contracting and suddenly it starts expanding. So at 4 degrees Celsius, the volume of the water is minimum due to contraction, because after this it starts expanding. So its volume is minimum at 4 degrees Celsius. The anomalous expansion of water, it helps preserve the aquatic life during the very cold weather. Let us see how. When temperature falls, the top layer of the water in the pond contracts, becomes denser and sinks to the bottom. A circulation is thus set up until the entire water in the pond reaches its maximum density at 4 degrees Celsius. If the temperature falls further, the top layer starts expanding and remains on the top till it freezes. Thus, even though the upper layer are frozen, the water near the bottom is still at 4 degrees Celsius, and the fishes and other aquatic animals, they can survive in it easily. The anomalous behavior of water can be studied with the help of Hope's apparatus. In Hope's apparatus, a flat bowl is attached to a cylindrical container as shown over here in the picture. There is a provision to attach thermometers above and below the flat bowl on the cylindrical container, that is T1 and T2 are the two thermometers that are attached below and above the bowl. Water is filled in the cylindrical container and a mixture of ice and common salt is put in the flat bowl. So, during the study of anomalous behavior of water using this Hope's apparatus, The temperature T1 and T2 are recorded after every minute. Initially, both the temperature T1 and T2 are identical. However, as time passes, the temperature T1 of the water in the lower part of the cylinder decreases very fast, while the temperature T2 of the water in the upper part of the cylinder decreases comparatively slowly. However, once the temperature of T1 in the lower part reaches 4 degrees Celsius, it remains almost stable at that temperature. T2 decreases slowly to 4 degrees Celsius. Thereafter, since T2 starts changing rapidly, it records 0 degree first, and after that the lower thermometer T1 records 0 degree Celsius temperature. Let us understand why this happened this way. Initially, the temperature of the water in the middle of the cylinder lowers due to the freezing mixture in the outer bowl. Since the temperature of the water there decreases, its volume decreases and its density increases because density is inversely proportional to volume. The water with higher density moves downwards. Therefore, the lower thermometer T1 shows rapid fall in temperature, and this continues till the temperature of the water becomes equal to 4 degrees Celsius. When the temperature of the water starts decreasing below 4 degrees Celsius, its volume increases and so the density decreases. It therefore moves in the upward direction. The temperature of the water in the upper part, that is T2, decreases rapidly to 0 degrees Celsius. The temperature of the water in the lower part, however, remains at 4 degrees Celsius only for some time and then decreases slowly to 0 degree Celsius. About 71% surface of the earth is covered with water. Due to constant evaporation of the water, water vapor is always present in the atmosphere. The amount of the water vapor in the atmosphere helps us to understand the state of the daily weather. The presence of water vapor in the air makes it moist. The moisture in the atmosphere is called humidity. For a given volume of air at a specific temperature, there is a limit on how much water vapor the air can contain. If the amount exceeds this limit, then the excess water vapor gets converted into water droplets. That is called dew. When the air contains maximum possible water vapor, it is said to be saturated with the vapor at that particular temperature. The amount of the water vapor needed to saturate the air depends on the temperature of the air. If the air temperature is low, it needs less vapor to saturate the air. And if the vapor contained in the air is less than the maximum limit, then the air is said to be unsaturated. Suppose an unsaturated air at a certain temperature is taken and then its temperature is decreased. A temperature is reached at which the air becomes saturated with vapor. This temperature is called the dew point temperature. So the dew point temperature is the temperature to which the air must be cooled to become saturated with water vapor. When it is cooled further, the airborne water vapor will condense to form the liquid water droplet, that is dew. The higher the dew point temperature, the greater the amount of water vapor is present. The water vapor content in the air is measured using the physical quantity called absolute humidity. The mass of the vapor present in the unit volume of air is called absolute humidity. The feeling of humid or the dry nature of air not only depends on amount of the water vapor that is present in the air, but it also depends on how close that amount is for making the air saturated with vapor. It means that it also depends on temperature. So, the ratio of the actual mass of the vapor content in the air for a given volume and temperature to that required to make the air saturated with vapor at that temperature is called relative humidity. The relative humidity at the dew point is 100%. You can see over here at 10 degrees Celsius, the relative humidity is 100%. Means what? The air has no more capacity to hold the water vapor. It is completely saturated. Whereas, if the relative humidity is more than 60%, we feel that the air is humid. And if the relative humidity is less than 60%, we feel that the air is dry. Here in both the cases, you can see at 20 degree and 30 degree, the relative humidity is 52% and 28% respectively. So it is less than 60%. Over here, you can see that still the air has capacity to hold more amount of water vapor. Only this much water vapor is there. The air has still the capacity to hold more amount of water vapor. Let us understand specific heat capacity with the help of one activity. Take 3 spheres of iron, copper and lead of equal mass. Put all the 3 spheres in the boiling water in the beaker for some time. Take the 3 spheres out of the water. All the spheres will be at the temperature 100 degrees Celsius. Put them immediately on the thick slab of wax as shown over here in the picture. Note the depth of each of the sphere that goes into the wax. The sphere which absorbs more heat from the water will give more heat to the wax. More wax will thus melt and the sphere will go deeper in the wax. It can be observed that the iron sphere goes deepest in the wax. Lead sphere goes the least and the copper sphere goes to intermediate depth. This shows that for equal rise in temperature, the 3 spheres have absorbed different amount of heat. This means that the property which determines the amount of heat absorbed by a sphere is different for the 3 spheres. This property is called specific heat capacity. The heat required to raise the temperature of the unit mass of a given substance by 1 degree Celsius is called the specific heat capacity. It is denoted by the small letter C. The SI unit of the specific heat is joule per degree Celsius kg and the CGS unit is calorie per gram degree Celsius. The specific heat of an object is C, the mass of the object is N, and if the temperature of the object is raised by delta T degrees Celsius, then the heat energy absorbed by the object is given by the product of M, C and delta T. Similarly, if the specific heat of the object is C, mass of the object is M, and if the temperature of the object is decreased by delta T degrees Celsius, then the heat energy lost by the object will be given by the product of M, C and delta T. If heat is exchanged between the hot and the cold object, the temperature of the cold object goes on increasing due to the gain of energy, and the temperature of the hot object goes on decreasing due to loss of energy. The change in the temperature continues till the temperature of both the objects attain the same value. Heat always gets transferred from hot to the cold body till the temperature of both the bodies becomes equal. Here, object 1 is at high temperature and object 2 is at low temperature. So the transfer of heat will be from object 1 to object 2, and this transfer will continue till both the object attain the same temperature. So the principle of heat exchange is heat lost by the hot object is equal to heat gained by the cold object. So here we complete this chapter. This is all for today's session. Thank you so much.